So let's proceed in the thermodynamic properties of the system. First we will discuss the specific volume, wherein the specific volume is equivalent to volume per unit mass. If you have an SI unit, you have m cube over kilogram, or m cube per kilogram. So you have the reciprocal. If you get the reciprocal of our specific volume, you have the density, wherein that density is mass per unit volume. This is kilogram per cubic meter cube. So this is V is equals 1 over rho. Okay. So you have that the density, you have also the specific weight, wherein you have weight per unit volume. This is also expressed in mass times gravity per volume. This is rho over gravity. Our SI unit is in Newton per cubic meter. So we have the specific gravity. This is equivalent to the specific weight of the fluid divided by the specific weight of water, wherein we have the specific weight of water given 9.81 kilonewton per meter cube. So we have our first example. Two liquids of different densities, given density 1 is equivalent to 1500 kilogram per cubic meter, and density 2 is equivalent to 500 kilogram per cubic meter, were poured together into a 100-liter container, filling it. If the resulting density of the mixture is 800 kilogram per cubic meter, find the respective amounts of liquids used. Also, find the weight of the mixture given the local density, or given the local gravity 9.675 meter per second squared. So we have our example. Try to solve this one. So given the density density 1500 kilogram per meter cube, and you have the density 2 500 kilogram per meter cube. This is poured these two liquids are poured into one container, which we have the final density of 800 kilogram per cubic meter. So you are to determine the mass of, or the respective mass of our liquids. So we are to determine the mass 1 and also the mass 2. We have also the volume of our container. We have volume 1 plus volume 2. We have 0.1 meter cube, and this is our equation 1 here. We have that equation. So can also express this as the this is the volume total over the density. This is 0.1, right? So since we have 0.1, this is the mass total here. Over the final density when two liquids are poured together, and we have this 0.1 cubic meter as our final volume. So therefore, since we have the density given, have the mass total here, this is 0.1 times the density 800. So we have the mass here. We have, this is 80 kilograms. Okay, that is 80 kilograms. So given the gravity here, local gravity of 9.675, this is meter per second squared. So you have the weight of our, you have the final weight, or the total weight. This is mass times the gravity. So this is 80 times this 80 kilogram times 9.675. Of the final weight. So we have the final weight. It is 774 Newton. Okay. Okay, we have mass 1 plus the mass 2. You are to determine this respective mass. This is equivalent to 80 kilograms. And we have the volume 1 plus volume 2. This is equivalent to 0.1. So we will express the volume here in terms of mass, since densities are given. So we have the mass 1 over 1500 plus the mass 2 over 500 is equivalent to 0.1. I'm going to simplify this one. This is mass 1 plus 3 m2. This is 0.1 times 1500. So therefore you have mass 1, which is equivalent to this is 150 minus 3 and 2. So we have our mass 1, 150 minus 3 and 2. So we're going to substitute mass 1 here and this one. So we have 150. We have 150 minus or plus 150 minus 180. No, 150 minus 3 m2. 3m2 is of course plus m2 equals 80. So we have the mass m2. This is equivalent to 35. This is 35 kilogram. So we have the mass m2. We can solve now for our mass m1. m1 is equivalent to, this is 80 minus m2. So our mass m1, this is 80 minus 35. This is m1 is 45 kilograms. Okay, you have the mass m1 and you have the mass m2. So next we will discuss another thermodynamic property. Here you have the pressure. So the pressure is force per unit area, or this is Newton per meter squared in SI units, or this is pound per square inch, or PSI. So the Newton over m squared is equivalent to Pascal. So we have kilonewton per meter squared, that is kilopascal or kPa, or that is 1000 Pascal. We have megapascal, that is 10 to the 6 Pascal. We have 1 bar, this is equivalent to 100 kilopascal. We have also some other units of pressure. You have terms of atmospheric pressure. Atmospheric pressure, this is equivalent to 101.325 kilopascal. And this is also equivalent to, this is 14.7 psi, and this is equivalent to 760 millimeters of mercury, or this is 29.92 inch of water. So these are some units of the, these are some equivalents of the atmospheric pressure. So to measure the atmospheric pressure, we have the device called the barometer. This is the instrument used to measure the atmospheric pressure. So as I've said, we have standard atmospheric pressure at sea level, that is 101.325 and or this is equivalent to 14.7 pound per square inch. Okay, so you have the absolute versus gauge pressure. What is this absolute, or what is this gauge pressure? The absolute pressure measured from absolute zero. This is the theoretical lower limit where molecules stop moving. Okay, and the gauge pressure, this is measured by a gauge reckoned from the local atmospheric pressure. And the vacuum pressure, this is pressure below atmospheric pressure. Vacuum pressure also indicates a negative sign. That is a negative gauge pressure. So to calculate the absolute pressure, we have this is equivalent to pressure atmospheric plus gauge pressure. So it is negative if it is vacuum pressure. That's why we have the plus minus here. This one. Yeah, that plus minus sign. Okay. It is negative, it is vacuum. Okay. So in order to relate these pressures in terms of the specific weight and the height, you have these manometers. So a pressure measuring device consisting of a U-tube and a measuring fluids such as mercury. So this is equivalent to pressure is specific weight times the height of the column of measuring fluid. Okay. So example number 2. In order to have a better understanding to solve this one. So if atmospheric pressure is 95.7 kilopascal and the manometer attached to the tank reads 188 millimeters of mercury vacuum, meaning this is negative, find the absolute pressure within the tank given the specific gravity of mercury is 13.6. So we have that one. So we have, in order, we have this absolute pressure. This is what? This is the atmospheric pressure plus or minus our gauge pressure. Since the, in our problem we have the vacuum, so that is negative. So atmospheric pressure minus this one vacuum. So we have given atmospheric pressure. We have 95.7 kilopascal. So if it is not given, that is we will assume the 101.325 kilopascal, that is at sea level. So only for this problem you have a given atmospheric pressure 95.7, but the standard, as we have discussed a while ago, that is 101.325 kilopascal. So for this instance we have 95.7 kilopascal. Okay. So now our problem, what is the absolute pressure? So we have the atmospheric pressure, that is 95.7. It is in kilopascal, minus 188 millimeters of mercury. So as you observe, we have different units. This is in kilopascal and millimeters of mercury. So we need to be consistent here. Whether we select the kilopascal or we will select the millimeters of mercury. So remember here you have the equivalent millimeters of mercury in terms of atmospheric pressure, that is standard. This one 1.325. Okay. So 95.7 Pascal will convert this one. So this is 1.325. This is equivalent to 760 millimeters of mercury. So this is 717.8 millimeters of mercury. You can check in your calculator if this is correct. So okay, so we can calculate now the absolute pressure here. That is 717.8 millimeters of mercury. We have now uniform units. Vacuum, that is negative. This is 1.8 millimeters of mercury. Therefore, we have our result. This is 529.8 millimeters of mercury. Okay. So that is the our answer for our sample problem. Okay, again. So this is negative because this is vacuum as stated in the problem. So remember that our pressure is, if this is our pressure, is dependent with the given, dependent with our dependent with the height. Okay, So if this is our reference point here, you have the reference point. This is the atmospheric pressure. It is standard, it is 101.325 kilopascal. Okay. Pressure is zero if the molecules stop moving. Okay. Pressure is zero here. So remember, for the vacuum pressure, have the sign is negative. Okay.